All right, so before we get going here today, two things that I want to remind you about or let you know about. First, we will have our Unit 3 test next week, Friday. Okay? So that's 9 days from today. We'll have the test. It'll cover everything that we've done in Unit 3. Okay? So that's make sure we get everything fixed, corrected, taken from Unit 3 before that day. Okay? We still have a couple of homework assignments in there and one more formative on next week, Tuesday. Okay? Second thing, next week, Wednesday, a week from today, I would like you to bring your Chromebooks to class because we need to register at the tech. We need to register for this class to get dual credit. Just because you're registering doesn't mean that you're actually going to take the credit, but you need to be registered if you want the credit. And it's easier to do it now than it is to do it in the spring. So with that being said, not only do you need to come with a Chromebook next week, Wednesday, but you also need your NTC ID number if you have one. If you've taken a dual credit class here at West before this one, you probably have an NTC ID number. If you haven't, if this is your first dual credit class, then you will need to bring along your Social Security number. Okay? Because that's how you got to get registered at the tech in order to get the NTC ID number in order to get the dual credit. Okay? Everybody will be registered, okay? But that doesn't mean everybody has to take the grade that they get in the class. Okay? It's just everybody. I just have to register everybody so that the possibility exists in May that if you want to take it, you have that chance. Okay? So, test next Friday. Bring your Chromebooks and your NTC ID number or your Social Security number on Wednesday. Okay? All right. So, today we're going to start topic 3.7. Topic 3.7 is going to take us today and tomorrow. Then we'll do topic 3.8 on Friday, Monday, Tuesday, formative, Wednesday, 3.8 still, and then Thursday, review. We'll have a review activity on that day, and then Friday test. Yep. I like topic 3.7 because we're finally getting into, we've done all the math up to this point in time, but now we're getting into some real math, okay? Where we're not going to get all these extra things in a problem, okay? We're going to find all the zeros of a polynomial function today, and we're going to do it without knowing any. Up to this point in time, we've either been given a factor or we've been given a zero, or it's been factorable. Now we're taking the gloves off, we're taking the crutches off, we're just going into some real math. Okay? So what we're going to utilize in order to do that is something called the rational zero theorem. The rational zero theorem says that if f of x equals that thing, and I understand that that looks confusing, but you can always think of it as f of x equals like 8x squared plus 17x. Oops, I should have done fourth there. I didn't want to do squared there. I wanted to do to the fourth. Minus 15x squared plus 9. Okay. We're just going to have a polynomial. then every rational zero of that polynomial is going to be of the following form, where it's going to be before I even get into that, the following form, P over Q, rational zero here is a fancy way of saying fraction. So we're going to find a zero, that's a fraction. And how we do that is we take a factor of the constant term a sub 0. Well, that's this term right here. The constant term is the term, the last term, the term without a variable, that term that is just a number. That's the constant term. Okay? So we take all the factors of that number and we divide them by all the factors of the leading coefficient. And that's going to produce a list. And from that list, we'll be able to find one of them, or two of them, or three of them, or in this case, we'd have to find four of them that are actually zeros. Excuse me. Okay. So, how we go about doing that is this. So I look at my polynomial. In this case, my polynomial is 2x squared plus whatever x minus 15 or plus 15. Doesn't matter what the signs are of them. Okay? But what I do first is I first look at, oops, not that number, tap the brakes. I look at that number. There we go. I look at 15. And I say, what are the factors of the number 15? Is that it? 3 and 5. Are those the only two factors of 15? 15 and 1. So we could write that as 1, 3, 5, and 15. And I like to write those out in numerical order. Then I look at this number and I say, what are the factors of 2? You got Nikki? 1 and 2. Okay. So now I can come up with my rational zero list. So I take every one of the factors of 15 and I divide them by the very first factor of 2. So 1 divided by 1 is 1. 3 divided by 1 is 3. 5 divided by 1 is 5. 15 divided by 1 is 15. So I've got 1, 3, 5, and 15. That's the start of my list. Then I take all of the factors of 15 and I divide them by the next factor of 2. In this case, it's just 2. I do that for every one of the factors of the leading coefficient. So what's 1 divided by 2? 1/2. 3 divided by 2, 3/2. 5 divided by 2, 5 halves. 15 divided by 2. 15 halves. And then, at the very end, because I can have negative numbers as my zeros, as my solutions, as my roots, as my answers, I slap a plus or minus on all of those. And those are all the possible rational zeros of 2x squared plus bx plus 15. Or minus, plus or minus. Okay. What we've done, utilizing the rational zeros theorem, is we've taken an infinite amount of possible answers. And we've narrowed it down. In this case, we've narrowed it down to 16 possible answers. Then out of those 16 possible answers, we're going to narrow it down to the final 2 in this case. Because it's a squared, I need to have 2 answers. Okay? So it's a weeding out process. Okay? If we go back to the beginning, that one that I said up here. If we say this one, oops, now I gotta tap without breaks here. There we go. And I say copy. And I say bring that down here. And I say, it's a 2-finger. Paste. There we go. Okay. So what are the possible rational zeros of this one? Well, what are the factors of 9? So 1, 3, and 9? That's what I'm hearing? Okay. What are the factors of 8? So based off of that, what is my rational zero list? When we're reading up the list, I'll assume that you're meaning plus and minus. What do I do first? Divide all the red ones by 1. Okay? So that's 1, 3, and 9. Next. Okay, what's that then? Is that it? Now I gotta divide it by 4. Now I gotta divide them all by 8. Okay. Try that one. List all the possible rational zeros of that function. What do we get? Okay, but no, what's my list? What's my final list?
1, 2, 4, 8, 1 half, 1, 2, and 4.
Sounds like you got a couple of repeats in there. Right? So would I have to repeat those? No. What's up? Eight has factors of 1, 2, 4, and 8. 2 has factors of 1 and 2. So that gives me a rational zeros list of those 10 values right there. Agree? Okay. Let's put it to work. Okay. I told you a couple weeks ago that where we want to go in this unit, with this stuff, is that we want to get to be able to just, here's a polynomial, solve it. Okay? Well, today we're going to get there. Okay? So there's a polynomial. Half of x equals x cubed plus 2x squared minus 9x minus 18. Solve it. Okay? So the very first thing that we are going to do with that is we're going to use the rational root zero theorem, and we're going to list out our potential zeros. Okay? Because right now we have an infinite amount of possible zeros. We want to narrow our search as much as we can. Okay? So I'm going to take 18. 18 has 1, 2, 3, 6, 9, and 18 as its possible factors. 1 has just 1. So my list, my possible zeros are those 12. From that list, now, what we're going to do is we are going to need to find at least one zero. How do we do that? Well, we pick a zero from our list. We're going to synthetically divide it in. And if our remainder is 0, it's a 0. There will not, just because we came up with our list, doesn't mean all of those are zeros. Okay? We came up with 12 possible zeros. How many of them are zeros? Well, 3 of them are zeros, if they were all rational. Or 1 of them would be 0 and 2 of them would be irrational. Okay? Because irrationals come in pairs. Okay? So, pick me a number off of our list. 9. Okay? So I'm going to synthetically divide 9 into my polynomial. 1, 2, -9, -18. 1, 9, 11, 99, 90, 810, -792. Is 9 a 0? No. Okay? So we've crossed 1 off the list. So now we've got 11. Still got to find 3. Give me another one. 3? Is 3 a 0? Yeah. Yep, 3 is a 0. Okay? So we found a 0. Now, we got lucky on the second one. Could have that taken us a couple of tries? Yes. Yeah. Just so happened. Good guess. Or did you know it? Oh. What was that? Oh, okay. I see. So you want, because 9 and 18 both divided by 3, you figured 3? That works. Huh? All right. Got lucky. All right. So then we go on to step number 3. Step number 3 says, now we can factor our new polynomial. So our original polynomial was f of x equals x cubed plus 2x squared minus 9x minus 18. Well, now, because 3 is a 0, what does that mean in terms of a factor? If 3 is a 0, x minus 3 is a factor. Now we struggled a little bit with this on the last couple of formatives. Okay? So if I'm factoring that and I know that 3 is a 0 or that x minus 3 is a factor, then this becomes x minus 3 times something else. Well, what's that something else? And I got that, or CJ got that, from right there. It doesn't just become x squared plus 5x plus 6. Because that's not equal to x cubed plus 2x squared minus 9x minus 18. Okay? If I multiply green and orange there, I get black back. Okay? Factor. So now, can we factor the orange even more? Are there two numbers that multiply together to be 6 and add to be 5? What do you got on? 2 and 3, both positive or both negative, or one of each? Positive. Both positive?
Yeah.
Huh? And then lastly, now we can take it in factored form and we can solve it. Okay? How am I going to go about solving this from its factored form? Okay. So x minus 3 equals 0. X plus 2 equals 0. And x plus 3 equals 0. And then what? So my zeros of this function, or my solutions to this polynomial, or the roots of this equation are negative 3, negative 2, and positive 3. At the beginning, I needed to find 3 of them. Luckily, they were all rational. If they're not, then we got to use Pythagoras or quadratic formula too. Okay? On this one, I gotta go down here now. List all the possible rational factors. That's like kind of like our new bus stop number 1. Okay? Is listing all the possible factors. Finding all the factors, that's kind of like our old bus stop number 2, where we completely factored it. Come on. Why is that doing that today? So what is my list? What are the possible zeros? What you got, Carter?
1, 2, 3, 3, 6, 9, 18.
All plus or minuses?
Yep.
Love it. Okay. Kyle, did you find one?
No,
Not yet? Okay. William, did you find one yet?
one.
One? What?
Is it one?
One? You sure?
I'm not sure.
I know you're not sure because you haven't even put your pencil to your paper yet. And we've been working on this one for about 7 minutes. Right? Okay, so let's put our pencil to our paper. Okay? So tell me what to do.
Well, that's why I didn't, because I kind of, the first one, I wrote down like half of it, and I didn't write down what you're supposed to do, so.
So what am I supposed to do with one?
No, that's what I'm saying, like I didn't write that down, so I don't know how.
This was the first half of
I know,
it.
so I
Oh.
wrote like half of it, and then I.
Oh, okay. All right. Well, all right. Somebody tell me what to do. That hasn't been participating very much today.
Synthetically divided
How?
using the top equation.
I'm a numbers guy.
1,
Okay.
negative 4, negative 15, 8.
Okay.
Drop the 1. Negative 3. Negative 3. Negative 18. Negative 18. Then 0.
Okay. So 1 is a 0 because we got a remainder there of it. Okay. So f of x, make sure we're still in f, yep, f of x is equal to what?
X minus 1.
Okay. Leo, what's the rest of it?
X squared minus 3x minus 18.
And is x squared minus 3x minus 18 factorable? Didn't get there yet? Two numbers that multiplied together to be negative 18 and add to be negative 3. Would you guys think?
Plus 6 and X minus 3.
Minus 6 and plus 3? Is that what you said?
Yes.
Because it's got to add together to be negative 3? Yours added together to be positive 3. Okay. So that's number 2. That's the factored part, right? It's amazing how all of a sudden everybody's ears perked up once I started calling on people. You don't want to be called on, start participating. Okay? With me? Danielle, now what? Okay. So I get zeros here, which was the third thing we wanted, of negative 3, 1, and 6.
So 6 works, could you just use it for the one and use it for the same stuff?
Yep. So yeah, if you would have started up here,
Yeah.
if you would have done 6, you would have found 6 first.
So it doesn't really matter which one you find first.
Nope.
You only have to find one.
Nope. Yep. You only got to find one. 1, 6, 2, 12, negative 3, negative 18, 0. So then that would have been yours. So then you would have factored it to be, oops. You would have factored it to be x minus 6 times x squared plus 2x minus 3. And then this one would have factored to be x plus 3, x minus 1. And then you would have gotten your 3 that way. Likewise, if you would have found negative 3, would have been the other 0 you could have found. Okay? Homework for this evening. Due tomorrow.